the most distant human-made object, NASA's Voyager 1 spacecraft, is in interstellar space. Well, this is the spacecraft, the first to interstellar space. We made it!
The furthest thing created by humans, Voyager 1 is a spacecraft operated by NASA that is the first to enter interstellar space. Prepare yourself for an interstellar stunner that will have you on the edge of your seat. Imagine a spaceship launched 45 years ago that continues to explore areas that were never supposed to be explored long after its planned lifespan. That is the mind-bending reality of a daring expedition. The NASA mission that's revolutionizing space exploration guidelines. But here's the really big deal. Not only is this intrepid spacecraft billions of kilometers from its launch pad, but it's also transmitting data back to its launch pad using equipment that's as antiquated as a cassette player. That's not all. Talk about a stunner. NASA's groundbreaking mission, launched in 1977, has just revealed a spine-tingling discovery that has set the scientific community abuzz and captured the attention of the entire world. What could this horrifying finding from the last frontier be, and what does it mean for us all back on Earth? Let's dive into the unknown and unlock the secrets of the cosmos. It was a moment in history when the stars aligned and two of the most awe-inspiring spacecrafts ever launched into space took flight. It was 1965, the dawn of the space exploration era, and Gary Flandreau, a brilliant mind at NASA's Jet Propulsion Laboratory, had a monumental task to plot the optimal path for a space probe to reach the distant giants of our solar system, Jupiter, Saturn, Uranus, and Neptune, armed with nothing but a pencil, a beloved precision tool of engineers in the 20th century. Flandreau made a jaw-dropping discovery. He realized that in the late 1970s and early 1980s, all four gas giants would align in a cosmic dance, forming a celestial necklace with Earth. This once-in-a-lifetime phenomenon meant that a spacecraft passing by each planet could gain a speed boost from their gravitational pull, like being pulled along by an invisible rope. Flandreau calculated that a journey from Earth to Neptune, June, which would have taken 30 years, would now be accomplished in just 12 years. Thanks to these gravity assists, there was just one catch. This alignment only happens once every 176 years. Not one to miss out on such an extraordinary opportunity, NASA swiftly sprang into action within a mere 15 days of each other. They launched two identical spacecraft named Voyager 1 and Voyager 2 in the summer of 1977. Aiming to make the most of this cosmic alignment, little did they know that these twin explorers would go on to shatter all records in the history of space missions. More than 45 years later, Voyager 1 and Voyager 2 are still going strong, sending back groundbreaking information from the farthest reaches of our solar system on a daily basis. They have outlasted any other spacecraft in history and traveled further than anyone could ever have imagined. Despite a remarkable feat considering that their original mission duration was only intended to be 4 years, but these interstellar pioneers had a few surprises up their sleeves early on in their epic journeys. They provided astonishing up-close views of the moons of Jupiter and Saturn, revealing a world far more dynamic and active than anyone ever anticipated with their Discover memories of active volcanoes and fidget ice fields. The Voyager spacecraft defied expectations and forever changed our understanding of these distant realms. As the only spacecraft to have undertaken such a journey thus far, Voyager 2 blazed a trail through the cosmos, becoming the first to venture close to Uranus in 1986, and then seeing past Neptune just 3 years later. These pioneering interstellar probes, no larger than a vintage Volkswagen Beetle, have defied expectations and continue to push the boundaries of our understanding. Over 14 billion miles from home, these spacecraft are alone in the universe. The explorers' epic journey started with Venus providing gravity support, a move that had never been tried by spacecraft en route to Mercury, making them real trailblazers. However, it wasn't a simple feat, with margins of error estimated in tens of minutes and several tries to get it right. Pioneer 10 and 11 blazed a path through the ostensibly dense asteroid belt unharmed. The first leg of their voyage to Jupiter took them to a distance 10 times farther from Earth than Mercury, and they had to navigate through the treacherous asteroid belt, a topic of much debate and speculation beforehand in the 1970s, paving the way for Voyager. But Voyager's challenges didn't end there with only 69 kilobytes of memory, equivalent to a fraction of a smartphone's capacity. The Voyager computers had to rely on onboard intelligence to manage the complexities of their journey. The data gathered by the instruments on board was stored on 8-track tape recorders before being transmitted back to Earth by a modest 23-watt transmitter, about as powerful as a refrigerator light bulb, equipped with 12 FT wide dish antennas. The Voyagers used radio communication traveling at the speed of light to send and receive messages, but their immense distance from Earth, advancing by 3 or 4 light seconds every day, presented challenges in staying connected. The signals from Voyager 2 took over 18 hours to catch up, and the growing interference from Earth's noise, including radios, television, cell phones, and more, made it increasingly difficult to hear the faint whispers from the spacecraft. Yet despite these obstacles, the voyages have defied the odds and continue to surprise astronomers with unexpected discoveries in the interstellar void. Their journey has rewritten our cosmic playbook and altered our understanding of the unknown. The mysterious art cloud is a celestial gathering of comet-like objects, bound together by the sun's gravitational pull that stretches halfway toward the nearest star. It is a far-off realm that the voyages are slowly but steadily making their way towards. But interstellar space, where the solar wind phenomena give way, is a more accessible frontier. Here is where the heliopause, the border between our solar system and interstellar space, marks the beginning of uncharted territory. Initially, estimates of the heliopause's distance before the voyage of probes reached it were inconsistent, but assuming it to be around 50 astronomical units U, the mission's funding was increased even as the spacecraft departed from this landmark. An abrupt increase in galactic cosmic rays, which are high-energy particles released from supernova and other cosmic catastrophes at nearly the speed of light, was one of the predicted signs of entering interstellar space. However, the majority of low-energy cosmic rays are deflected by the massive magnetic shield formed by the heliosphere, which shields our inner solar system from the majority of external threats. When the spacecraft descended farther into the interstellar medium, which is made up of ionized gases and is influenced by nearby stars, the Voyager team was also closely monitoring any changes in the dominant magnetic field. This was because it was expected that this medium would have a different magnetic field orientation from the heliosphere, but the Voyages reported no such alterations, which added to the mystery. Finally, on August 25, 2012, Voyager 1 crossed the heliopause and transmitted back fascinating data, which confirmed the expected increase in plasma density, but showed no signs of a shift in the ambient magnetic fields. Guide. This was unexpected because it was expected that when moving from an area where the sun's magnetic field predominated to one that was influenced by other stars, a change in magnetic field direction would occur. In November 2018, Voyager 2 set out on an incredible journey to the interstellar seashore, arriving at the heliopause, the boundary of our solar system, 120 astronomical units from Earth, the same distance traveled by its twin 6 years earlier. However, what baffled scientists was that Voyager 2 detected no changes in the magnetic field as predicted by theoretical models, adding yet another mystery to the mix. The solar wind was at its strongest when Voyager 2 arrived, suggesting that the heliopause should have been farther out than 120 AU as the Voyager probes observed. However, none of the models in existence could explain this discrepancy. Predictions stated that the heliosphere, which is influenced by the sun's 11-year cycle, should have ebbed and flowed similarly to the solar wind. As one approaches the interstellar medium, data from this region reveals intriguing small-scale changes near the heliopause that are influenced by interactions with the heliosphere. However, at large scales, the magnetic field exhibits negligible variation, raising concerns about whether the spacecraft will eventually leave these turbulent shores behind and encounter the true interstellar magnetic field, or if the current understanding of the simulation is completely off the mark. An interstellar probe is necessary to shed light on one of the most fundamental mysteries about the heliosphere. However, just as some technologies like answering machines, BCRs, and pennies have become obsolete, the Voyagers continue to defy the odds with their antiquated yet resilient systems. Some academics speculate that the Voyagers may still be within the heliosphere, while others are convinced by the significant increase in galactic cosmic rays and plasma density detected by the probes. Pointing towards the majority opinion, these spacecraft's creators couldn't have relied on intricate lines of code because they are powered by technology from 50 years ago and require little software to function. Powered by a device that turns heat from plutonium's radioactive decay into electricity, Voyager 2 appears to have 5 operational instruments, while Voyager 1 has 4. However, NASA has had to switch to a triage mode because the Voyager's power output is decreasing by about 4 watts annually. The missions began 3 years ago. When the government discovered the heliopause transit, engineers had to turn off the heater for the cosmic ray detector, a vital device. Despite everyone's assumption that it would malfunction, the sensor continued to work even in extremely hot temperatures that were much over its measured limits. A truly astounding feat. The magnetometer and the plasma science instrument are expected to be the last instruments to shut down, as they are located inside the spacecraft's main body, warmed by the heat produced by the computers, while the other instruments are mounted on a 43-foot-long fiberglass boom. What lies ahead for the Voyages, if all goes according to plan, scientists might be able to extend their missions until 2030. But the real game changer is power. It's the determining factor. Even though the Voyagers will keep forging ahead undeterred by challenges in a mind-boggling timeframe of 16,700 years, Voyager 1 will pass by Proxima Centauri. Our closest neighboring star, Voyager 2, will follow suit 3,600 years later. After that, they will continue to orbit the galaxy for millions of years long, after our sun has faded away and the heliosphere has vanished. These resilient spacecrafts will still be there, largely intact. Unlike our tiny blue planet, perhaps they may even deliver a final message at some point during their endless journey. However, it won't be transmitted over the radio, and if it is, there won't be any humans. The Voyager's story is still a monument to scientific curiosity. Please share your opinions about the Voyages in the comments section below.